Now let's talk about the magnetism from electricity. Of course, for the first sight, someone will expect that there is no relation between magnetism and electricity, because magnetism, it comes from the magnets, that's objects which attract the iron containing objects, and electricity, for example, if we are talking about the electric current, it just represent the movement of the electrons through a wire. So what's the relation between them? Actually, physicists found strong relationship between them. That's the magnetism can produce by electricity. Easily keep in your mind, that's easily, if we have a wire and there is electric current pass through this wire, this will create magnetic field around it. To understand this one, let's look at this circuit here. We have here that's there is a resistor, we have a wire, but there is no electric current. Now at any time, if we add here a battery, this battery will of course as a result of adding the battery, we have electric current will pass from the positive terminal of the battery to the negative terminal. As a result of the electric current, magnetic field will produce. Now to see this, let's add here battery. Look at this. We have electric. You see, this is the red line represent the electric current. So the red line here represent the electric current I. And these circular lines represent the lines of magnetic field B. As we can see that the magnetic field will be in the form of circles around this straight line wire. So at any time when we have electric current pass through a wire, then there is magnetic field produced around it. Of course, if we have weak or a weak electric current, then we have a weak magnetic field. Okay, now how can we see this experimentally? How can we see how can we see these lines of magnetic field? By two different ways. The first one by iron filings, as we can see here that if we have no electric current, the iron filings will take random direction, will distribute it randomly on a paper. But if we have electric current, we can see that this iron filings start take a circular form. Look at this. Just increase the electric current to increase the magnetic field, and look at these. Now it seems that these circles represent or indicates to the lines of the magnetic field. So as we can see, the lines of the magnetic fields, there are circles around the wire similar to these green lines. Or we can use the compass. Now if we have no magnetic field, then if you put the compass here, it will not be affected by anything. But if we add the compass and there is magnetic field, we can see that the compass will take the direction of the magnetic field at the specific point. Now let's move the compass around the wire. Look at the needle of the compass, how change its direction. Change its direction according to the magnetic field, and look how rotate as in circle when we move it from one position to another. This is direct indication about the lines of the magnetic field. So at any time, if we have electric current pass through a wire and we put compass near this wire, we will find that this compass will be affected by the magnetic field. Now the question is, how can I define the direction of the magnetic field theoretically without compass of iron filings? Let's imagine that we don't have compass or iron filings. How can I define it? We define it by something, it's called right hand rule. The most important point about the right hand rule is that's right hand. We add the word right hand in purpose, just to remind you always that use your right hand. Never use the left hand. Always and always use the right hand to specify the direction of the magnetic field. How can I apply this right hand rule? Easily point the thumb of your hand, point the thumb of your right hand in the direction of the electric current. So here the electric current directed upward, then put the thumb in the direction of the electric current up, then curl the other fingers. The curls of the other fingers represent the direction of the magnetic field. So as we can see here that the magnetic field is directed counterclockwise. Now let's see what will happen if we switch the direction of the electric current. Now the electric current directed downward. Also use your right hand, always your right hand, the thumb in the direction of the electric current, similar to the simulation here, The curl of the other fingers will represent the lines of the magnetic field. So here the magnetic field, it's so clear that it's counterclockwise. It moves in the opposite way of the hands of the clock. Look, it moves, for example, from here 6 to 7 to 8. I'm sorry, this is clockwise. I'm so sorry. This is clockwise, not counterclockwise. Clockwise, it means that the lines of the magnetic field rotate around the wire similarly to the hands of the clock. So this is the right hand rule. Let's take some examples about the right hand rule to understand it. For example, let's imagine that here we have, as we mentioned, that here we have a wire and the electric current directed upward. Then the magnetic field will be circles. Now counterclockwise or clockwise, let's apply the right hand rule. Put your thumb in the direction of the electric current, rotate the fingers. For this case, it will be counterclockwise. So here it will be counterclockwise. Of course, we will ask ourselves, if counterclockwise, how can I represent this magnetic field? Counterclockwise, it means that at this point here, at this area here, let me use this here, it will be, just imagine that it's counterclockwise. It means that will be out of the page, or out of the screen, will be directed from the screen toward your face. Again, from the screen toward your face. While here, it will be enter the screen, into the screen. So it seems like if directed from your face toward the screen. So how can I represent this? Usually, if you want to represent anything which comes from the screen out of page or out of screen, out of your the screen of your device, out of the screen of the laptop or the screen of your mobile if you are using the mobile, then we draw here a dot. This dot, it means that the vectors is coming from the screen toward your face. While if we have into the page or into the screen, if you are using the laptop or mobile, then we put cross. Cross, it means that here at this point, the lines or the field or the vector is coming from your face and toward the screen, into the screen. So counterclockwise, it means at this point we have a dot, because here the magnetic field will be out of the page from the screen toward your face. I said page or screen, I mean the same thing. And then rotate, and at this area will enter the page. So the lines of the magnetic field will be, we can represent them like this. If we cannot draw them as a three-dimensional image, we can represent them like this. Now, for example, another example, if we have a wire like this is I, then put your thumb in the direction of right hand, the thumb of your right hand, put them in the direction of the electric current, rotate the finger, you will find that here at this area, the magnetic field will come out of the page toward your face, so I'll put here dot, then rotate, and at this page here, at this area here, will cross, so enter the page or enter the screen. So this is another example about it.